Welcome to this tutorial on stacking with np.stack. In this lesson, we'll explore how to create new dimensions in NumPy arrays by stacking them together. This is an essential technique for array manipulation and data organization in NumPy. np.stack is a NumPy function that joins a sequence of arrays along a new axis. The key difference between stack and other combination methods like concatenate is that stack creates an entirely new dimension in your output array. This means you're not just joining arrays end to end, but creating a whole new structural layer. The basic syntax of np.stack takes two main parameters. The first parameter is arrays, which is a sequence of arrays that all must have the same shape. The second parameter is axis, which specifies the axis along which to stack the arrays. The default value for axis is 0. Understanding these parameters is crucial for controlling how your arrays are stacked together. Let's look at a simple example using axis equals 0. We create two one-dimensional arrays. Array A contains 1, 2, 3, and array B contains 4, 5, 6. When we call np.stack with both arrays and set axis to 0, the result has a shape of 2 by 3. This means we now have a two-dimensional array with 2 rows and 3 columns. Here's how the stacking works visually. Array A, which is 1, 2, 3, and array B, which is 4, 5, 6, are combined into a single stacked result. The output is a two-dimensional array where the first row contains 1, 2, 3, and the second row contains 4, 5, 6. Notice how the arrays are stacked vertically, creating rows in the new dimension. Now let's see what happens when we change the axis parameter to 1. Using the same arrays A and B, when we call np.stack with axis equals 1, the result shape becomes 3 by 2 instead of 2 by 3. This is because we're stacking along a different axis, which changes how the arrays are combined. With axis equals 1, the stacking works differently. Array A with values 1, 2, 3, and array B with values 4, 5, 6 are now stacked to produce a 3 by 2 array. The result shows 1 and 4 in the first row, 2 and 5 in the second row, and 3 and 6 in the third row. This demonstrates how changing the axis parameter alters the structure of your output array. Let's summarize the key points about np.stack. First, all input arrays must have the same shape, otherwise the operation will fail. Second, stack creates a new dimension in the output array, increasing its rank by 1. Third, the axis parameter determines where the new dimension is inserted in the array structure. And finally, the output rank is always 1 greater than the rank of the input arrays. Understanding these principles will help you effectively use np.stack in your NumPy projects.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.